Hi all. Today we are going to demo the workflow of the CentOS Community Container Pipeline. To begin with, I need a project that has a Docker file in it and is ready to be containerized. As a developer, I do not want to worry about building, testing, and developing my application's container image every time I push an update to my application. That's where the CentOS Community Container Pipeline comes handy. Today, I'll try to integrate the HTTPD project in my fork of upstream CentOS Docker files repository. All I need to do is put a file named ci.centos.org.yaml containing the metadata to be used to build the container image. Among other data, I have specified the name of the image to build and the version of the image to be built. Once the changes are done and I have committed my changes to my repository, I need to go to the CentOS container index repository, which is currently at github.com/rtmpro/centos-container-index. So I need to go to the project-index.yaml file, which is the index of all the projects integrated with the system, and edit it to include my project, which I name as CentOS, and I'll paste the link to my repository. Since the Docker file is not in the root directory of my repository, so I need to specify the path related path to it. So, which in this case happens to be httpd-centos7, and a commit message, and I'll create a new branch and submit a pull request. So I've submitted my pull request. Once this pull request gets reviewed and accepted, my project is all set to automatically build, test, and deliver container images without me needing to even lift a finger. Since I'm the owner of this repository, so I'll go ahead and merge the pull request myself. Merged. Yeah, so the project index now contains link to my project. Now let us have a look into how the CentOS Community Container Pipeline actually works. I've got a Jenkins instance at web.pco.centos.org. It has a job named cccp-index, which is configured to poll the container index repository at regular intervals. On run, it creates or updates jobs for the projects listed in the container index. We see such jobs getting created over here. The jobs created for the individual projects in turn polls the remote project repositories and schedules container builds for them on our container build, test, and delivery pipeline, which is powered by OpenShift. Once this job runs, we see that a build is scheduled on the OpenShift server we're running. Now we'll take you through how we use OpenShift to empower our build, test, and delivery pipeline.